Today we're going to talk about solving systems of equations with three variables. And right from the beginning, I'm going to apologize for the shadow that the document camera is creating. You'll have to forgive that, but I can't make it go away. So hopefully it won't be too distracting. So, moving on to the actual math portion. So to solve a system of equations that has three variables, what we're going to first do is we're going to pick two equations out of our three, where we can easily eliminate one variable. So if I look here, I have a y in my second equation that is by itself, so I'm going to choose the first two. I'm going to call these first two equations, we're going to call them A, just so we can reference those back here in our directions. So I'm going to take these two equations and I'm going to write them off to the side. Okay, I'm going to treat these two equations just like a normal system of equations with two variables, and I'm going to eliminate, I'm going to focus on the y term, and I'm going to choose that to eliminate. So I'm going to multiply the second whole equation by 6. That way I can have a negative 6y plus 6y. So I'm going to rewrite my first equation. Now I'm going to rewrite my second after I've multiplied it by 6. Now I will add my two equations. Okay, so now what I'm going to do is I'm going to take another combination of equations, and I'm going to use the equation I didn't use the first time, so that's the last one. And I'm going to pick either one of the ones I did use, so I can use the first or the second. I'm going to choose to use the first, just because of this y by itself. I'll cancel it out with the 6. So I'm going to call the first and the second my B part. So I'll rewrite those equations. Okay, so now I'm going to multiply the second equation by 6 again. So I'll get 18x plus 6y minus 48z equals negative 168. All right, so now I'm ready to add my two equations. I'll get 20x, my y terms will drop out, minus 39z equals negative 176. Okay, so now what I'm going to do is I'm going to take both the result from my part A, the result from my part B, put them together to make a system of equations with two variables, because I eliminated the y on both sides, on both steps. That's very important. You want to make sure I chose to eliminate y here. I had to choose to eliminate y for my B section. If I didn't, this part wouldn't work. I would have a y here and not here, and I wouldn't be able to combine them to a new system. So I'm going to take this and rewrite them to make a new system. So if you're following along, that's step 3 up here. Okay, I now am going to solve this system. So to do that, I need to eliminate a term. So I can choose x or z. In this case, I'm going to choose to eliminate x. I'm going to multiply the first equation by 5, and I'll multiply the second equation by negative 8. So here I'll get 160x plus 105z equals 260. For my second equation, I'm going to get negative 160x plus 312z equal to 1,408. Now I'm going to add these two together. I ran out of space, so I'm going to use an extra sheet of paper. When I add them together, my x's will drop out. My z term will be 417z equal to 1,668. Divide by z and divide by 417, and z equals 4. So now I've solved for one of my variables. I need to solve for the other two. So now what I'm going to do is I'm going to take my z and I'm going to plug it back into either one of these equations and solve for x. In this case, I'm just going to plug it back in here, just because. So I have 32x plus 21 times 4 equals 52. I simplify this, and I should get x equal to negative 1. Now I've solved for two of my variables. So now I'm going to take these two, plug them back into one of my original equations to solve for the third variable, which is my y. I'm going to pick the last one. So I'm going to say 3x is negative 1 plus y minus 8 times 4 equals negative 28. So I get negative 3 plus y minus 32. Y should equal 7. So now I have solved for my three variables. The way we write our answer is in parentheses, and then we're going to write x, y, and z. So x, comma, y, comma, z. And that is our answer for our system of three variables. Okay, now we're going to move on to the second one. So we're going to do the same process. We're going to choose two equations that we're going to start with to eliminate one variable. I, again, like this y being by itself, so I'm going to choose the first two. I'm going to call that my a part. Rewrite those. Okay, I'm going to multiply the first equation by 4. Get 16x plus 4y minus 12z equals 45. Now, you may be thinking that I could have just added these two equations and gotten rid of the z. That is a very valid point. I could have done that. And then it would have meant that I would have had to eliminate z with this 11 and one of these 3's. So I would have had to multiply twice for that. So I was choosing not to do that. If you want to try to eliminate the z and continue to solve it, we should get the same answer, even if you do that. I'm going to continue out with this one. But again, if you want to try it a different way, absolutely go for it. Oops, this should be 180, not 145, or not 45. So I get 180 there, and those two, I should get 221. That looks a little better. So now for my second two equations, I'm going to pick the first one and the last one again. I know I'm picking the same ones, like the first two and then the first and the last. You don't have to do that. You can pick any combination, but I do need to still eliminate y, because that is the variable I chose to eliminate in my first set. So here I'll multiply the first equation by 7. Add these two together. 30x minus 32z equals 400. So now this is the part where I take these two equations, put them together to make a system. With two variables. So here I have to choose to eliminate x or z. Neither one is really pretty. I'm going to choose to eliminate z. I'm going to multiply the first equation by 32, the second equation by -9. So then I will get 704x minus 288z equals 7,072. And then my second equation will get negative 270x plus 288z equals negative 3,600. I add these two together. My z's will drop out, leaving me with 434x equal to 3,472. I divide by 434, and I will get x equal to 8. So now this is where I take my x and I plug it back into one of these equations. Doesn't matter which one. I'm going to say 22 times 8 minus 9z equals 221. If you solve this, we should get z equal to -5. I now take both my x and my z, plug them back into one of these to solve for y. I'm going to choose the first one. 4 times 8 plus y minus 3 times -5 equals 45. We simplify. We should get y equal to -2. Putting that all together, I write x, y, z. And that is my answer to my system. Okay, if we move on to the back, for number 3, go ahead and try number 3 on your own. So pause the video, try number 3, then resume the video to check your answer. So here's the answer to number 3. So you may have solved it a different way by eliminating different variables, but we should still end up with the same answer of -7, 0, and -3. Number 4 is going to be your knowledge check number 1 question, and number 5 is your knowledge check number 2 question. So you can work those out here, and then you will complete those answers online on Vision for your knowledge check. So we're going to move on now to word problems with 3-variable systems. So the word problems with 3-variable systems is very similar to word problems with 2-variable systems. The first thing you need to do are write down your equations that you get from the word problem, and then you're going to follow the same process for solving as we have already been doing. So here I have 3 types of tickets: general admission, senior citizen, and child. So those are most likely going to be my variables. Mark bought 9 general admission, 2 senior citizen, and 3 child tickets and paid $170. So I'm going to call my general admission X, senior citizen Y, and child ticket Z. So Mark bought 9 general admission, so that's 9x, 2 senior citizen, 2y, and 3 child, 3z. And he paid $170. Sarah bought 5 general admission, so that's 5x, 4 senior citizen, so that's 4y, and 7 child. And she paid $173. Kyle bought 4 general admission, so 4x, plus 1y, 1 senior citizen, and 6 child tickets, and paid $116.50. So those are my 3 equations. I'm going to solve them the exact same way as I have been with my 3 variable systems. So I'm going to pick 2 equations. I'm just going to pick the first 2. To eliminate here, I'm going to multiply the first equation by -2 so I can eliminate my y's. So I'll get -18x minus 4y minus 6z equals -340. I'll rewrite my second equation. Then I will add the 2 together, giving me -13x. My y's will cancel, plus z equals -167. So now I'm going to choose the first and the last equation. So here I eliminated y, so I need to do the same here. I'll multiply the second equation by -2. Okay, so now I'm ready to add these 2. So I get x, my y's cancel, minus 9z equal to -63. I'll combine these 2 equations. I want to eliminate one variable. I'm going to choose to multiply the first equation by 9. You could also choose to multiply the second equation by 13, but just choose one or the other. And then I will copy my second equation, add these 2 together. So I should get -116x, my z's cancel, equal to -1,565. I divide this by -116. I do need to round a little bit, but I get 13.50. So that means my general admission ticket is $13.50. I'm going to take that, plug it back in here. 1350 minus 9z equals -63. If I solve that for z, I should get z equal to 850. You'll get 8.5, but again, you need to remember that we are dealing with money. Then I would plug those 2 back in, so I'm going to say 4 times 1350 plus y plus 6 times 8.5 equals 116.5. You simplify for y, we should get y equal to 1150. So my general admission ticket is $13.50. My senior ticket is $11.50. And my children's ticket is $8.50. You're going to do number 7. This is knowledge check, question number 3. So you'll do that question and again enter it on Vision for your knowledge check. The last part, these are examples in which substitution may be better than elimination. So far we've been solving all of our systems with elimination, but given these word problems, substitution is better. So Mason has a collection of 49-cent stamps, 20-cent stamps, and 3-cent stamps worth $23.55. So I'm going to call 49 cents X, 20Y, 3Z. A little hard to read, so I apologize for that, but X, Y, and Z. So I'm going to make an equation here. So I have 49 cent stamps. So he has a certain number of those, plus the number of 20-cent stamps, plus the 3-cent stamps, equal a total of $23.55. My next sentence says he has 56 total 49-cent stamps and 20-cent stamps. So that just involves 2 variables. If I take 49, my number of 49 and 20-cent stamps combined, I should get 56. So here I should have X plus Y equals 56. And then my last sentence says, the number of 3-cent stamps is 9 more than the number of 20-cent stamps. So my number of 3-cent stamps equals 9 more than the number of 20-cent stamps. So here you can see I have one equation that has 3 variables, but these 2 equations each have 2 variables. So what I can do here is rearrange these 2 so I can substitute them back into my first equation to then solve for my system. So I'm going to solve both equations here. If I rearrange my second equation, so it's X equals 56 minus Y, I can substitute this in for X. I can leave this equation like it is and substitute this in for Z, and that would leave me with all Y's. So I'm going to substitute 56 minus Y in for X. I leave my 0.2y alone. And then here for z, I am going to substitute y minus 9, or y plus 9, excuse me. All equal to 23.55. So now I can just simplify this all the way down and solve for y. Here I should get $27.44 minus 0.49y plus 0.2y plus 0.03y plus 0.27 equals 23.55. If I combine like terms, I should get negative 0.26y plus 27.71. Solve for y, and we should get 16. Then I'm going to plug 16 back into these 2 equations to solve for my other 2 variables. So here I'll get x equals 56 minus 16, which means x equals 40. Then here I'll say 16 plus 9 equals z, so z equals 25. So now I've solved for all my variables. So I have 49 cent stamps. I have 16 20-cent stamps, and 25 3-cent stamps. Okay, this is knowledge check number 4, question number 4, and knowledge check question number 5. So you'll finish those two. You'll answer all your answers on the knowledge check on vision.